All right, so we're going to finish up this unit 5.1. This is the second part, and then we're going to look at some operations um, and how we can use those operations to simplify with fractional exponents. So I put back all the exponent rules again from the first lesson. So when we're multiplying, we add exponents. When we have exponents, raised exponents, think of distributing, so we multiply exponents together. When we're dividing, we want to subtract exponents. Anything to the 0 power is 1. Anytime we have a negative exponent, we want to flip it from the numerator to the denominator, or if it's in the denominator, move it up to the numerator to make it a positive exponent. All right, so let's go ahead and look at these operations, using these operations one at a time. So number 4, we're multiplying. So it's x to the 10 thirds times x to the 2/3. Okay, so you got to think that's a multiplication problem. So this multiplication problem is just like above. Well, what does it say when we're multiplying? We keep the base, but we add the exponents. So it's 10 thirds plus 2/3. Okay, we're adding those fractions together. So how do we add fractions together? Well, if the bases or the denominators are the same, then we can carry the denominator across and add the numerators. Well, since they're already the same, that's going to be 12 thirds. 12 thirds can simplify to 4. All right, so x to the 4th power. If the denominators were not the same, then you have to get them to be the same. You got to find the LCD, just like we did at the end of last semester. Right? So when we had fractions, you got to think when adding and subtracting, you got to have the same denominator. If they're not the same, then you got to find the LCD and get them to be the same. If you have calculators that have fractions on them, you should be able to just put it in the calculator and it'll do it for you. All right, so you should practice finding that key on your calculator also. All right, so number 4, again, we're multiplying and the bases are the same, so we keep the base, 2, and we add the exponent. So 13/4 plus 7/4, and so that's going to be 20/4, which is 5 to the 5th. And we can multiply that out. That's going to be 32, I believe. All right, number 5. Here we have an exponent raised to an exponent. So when that happens, you want to think of distributing, multiplying. This is where we multiply exponents together. So that 10, we can make that a fraction by putting it over 1. And you want to think when you multiply fractions, you can cross cancel, you can multiply across first, and then simplify. It's up to you. All right, so I'm going to go ahead and cross cancel first. Okay, because I know I can divide 5 into 10 turns it into a 2. So now when I multiply across, that's going to be negative 1 times 2 is negative 2 over 1 times 1 is 1. So I get 5 to the negative 2 power. All right, so we don't want negative exponents, so we're going to think of this as a fraction over 1, and now flip it to the denominator. So it becomes a positive 2. And now we can multiply that out. So 1 over 25. All right, number 6, we have 100 as our base. They're the same, so that means that we can subtract exponents. And we want to bring the smaller one to the bigger to do the subtraction. I know 7 over 2 is 3.5. And on the bottom I have 3. So the bigger exponent's on top. So I'm going to subtract and put them on top. So it's 100 to the 7 over 2 minus 3. All right, so again, 7 over 2 is the same as 3.5 minus 3. So that's just going to get us a half left over. And 100 to the half power, well, I can convert that to a radical. That's the same as the square root of 100. And then the square root of 100 is 10. All right, number 7. Here we have an exponent raised to an exponent. So again, we want to use multiplication. That's 10 over 1. I could cross cancel, simplify these fractions down a little. Divide by 2, that becomes a 3, and that becomes a 5. So now I have x to the 5 over 3. Now, x to the 5/3, there's really nothing wrong with that answer. It doesn't simplify. Let's see, what does it say? The answer should have no fractional or negative exponents. All right, so we want to go ahead and convert this to a radical. So this is cube root x to the 5th power. All right, now we can simplify this a little bit, and I'll show you how. When the bigger number's on top, all right, so this is really 1 2/3. All right, so since the bigger number's on top, you could change this to a mixed fraction. If the bigger number's on the bottom, then you can't change it to a mixed fraction. But because it's on top, bigger one's on top, this is the same as 1 2/3. So when you simplify problems like this, when you have a radical and you have a bigger exponent inside the radical, okay, that's bigger, then the index number, that's smaller, we can simplify this. So what you do is you ask yourself, think of mixed fractions. This is really how it works. So how many times does 3 go into 5? Okay, well, it goes into it 1 time. So what we do is we're going to pull that x to the first, that 1 time that it goes into it on the outside, and then ask yourself, well, what's the remainder? Well, once we divide 3 into 5, there's a remainder of 2, right? So there's an exponent of 2 left over. Now, the exponent on the inside is smaller than the index number on the outside. Right? So again, it's all you're thinking of is if you can change this to a mixed fraction, then it can simplify when you convert it to a radical. So the 1, the 2, and the 3, just so you can see where they're all located. So it simplifies down to x cube root x squared, or x times cube root x squared. All right, so just be on the lookout for that. All right, so number 8, 1/3, b to the 1/3 times b to the 2/5. So we have the same base, so we're going to be adding exponents. 1/3 plus 2/5. So again, if you have your calculator and you can put 1/3 plus 2/5 in it, great. If not, you need a common denominator, which is going to be 15. All right, so you're going to have to multiply the first fraction by 5. And the second fraction, to get it to be a 15 on the bottom, 3. So now it's 5/15 plus 6/15, which is now 11/15. All right, so b to the 11/15. Now, can you think of, like the last problem, can you convert this to a mixed fraction? Well, no, because the bigger number is on the bottom. So you can't convert it to a mixed fraction. So once we convert it to a radical, 15b11, this can't simplify because of the smaller exponents on the inside and the bigger ones on the outside. All right, number 9. So it looks like the same thing. We're multiplying. So that means we're going to be adding exponents. 1/4 plus 1/3. So we need a common denominator. And so it looks like it's going to be 12. So we're going to multiply the first fraction by 3 and the second fraction by 4. So now that becomes 3/12 plus 4/12, and that's 7/12. So we want to look, could we convert this to a mixed fraction? No, because the bigger one's on the bottom. So now when we convert it to a radical, we know it won't, we don't have to worry about simplifying it. All right, 10. Here we have an exponent raised to an exponent, so that means we're multiplying. So we're multiplying fractions. Now, since we're multiplying fractions, we can cross cancel. So I could cancel the 7s, become 1. I could cross cancel the 3 and the 15, make that a 5. So now when I multiply across, I'm going to get x to the 5 over 1 That's the same as just x to the fifth. All right, and that's all you do.